Good afternoon. This is Theresa Stack, Associate Professor for Montana Tech. In our learning unit today we'll cover confined spaces. You can find confined spaces under 29 CFR 1910, Subpart J. And if we take a look at the Occupational Safety and Health Standards, you can see that Subpart J has a number of different subcategories to include sanitation, color coding, and as well permit required confined spaces, as well as control of hazardous energy, which is lockout tagout. So it doesn't stand alone, and by that I mean that, for example, subpart E is egress. Here we find permit required confined spaces under subpart J, which is general environmental controls. So the scope, it applies to all employers that protect their employees in general industry when they have to enter a confined space that is considered a permit required confined space. So again, this is general industry, does not apply to construction, agriculture, or shipyard. And when you select the link in the PowerPoint, it'll take you to the OSHA standard, where you can see the definition for confined spaces as well as a quick OSHA card. This goes along with your confined space permit, which you find in the material that you bought supplementary for the class. It also gives you the procedures for atmospheric testing, as well as confined space when you're working in outdoor environments, and special considerations with hydrogen sulfide, and when you're working in grain operations. So there's a huge part of the OSHA standard and rules which can cover confined space. And this is specifically because a total of 136 workers were killed in incidents associated with confined spaces in 2015. That's about one death every 4 days. One study concluded that 40% of confined space fatalities involved attempts to rescue somebody who had gone down inside of a confined space. 100% of the air monitoring causes could have been prevented by proper air monitoring, and 61% of the deaths related to physical hazards could have been prevented as well. So what is a confined space? So 29 CFR 1910.146 subpart B, a confined space is large enough and so configured that employees can bodily enter and perform work, but it has limited or restricted means for entry, such as a tank, vessel, silo, pit, vault, or hopper, and it is not designed for continuous employee occupancy. So you can have a confined space which is so configured that it is not designed for continuous employee occupancy, but yet large enough that you can go into and perform your work. And that may be a confined space, but not necessarily a permit required confined space. So a permit required confined space is a confined space and then takes it one step further. So a permit required confined space contains or has the potential to contain a hazardous atmosphere, has an internal configuration such that the entrant, which is the person who enters the confined space, could become trapped or asphyxiated by inwardly converging walls or floors that slope downward or tapers in small cross sections. So for example, if you have to climb over baffles. A permit required confined space may contain materials that has the potential to engulf the entrant, such as a grain silo, or contain other serious safety and health hazards that aren't defined in 1 through 4. So therefore, not all confined spaces are permit required confined spaces. So some examples of confined spaces: silos, pits, vaults, tanks, and hoppers. And now you can see that walking and working surfaces, fixed ladders, may apply here. Here's another example of a confined space. So you can imagine a 5,000-gallon storage tank. It's large enough for me to enter and perform my work, but the entry portal may be so small that it's difficult for me to rescue, or that it could contain a hazardous atmosphere. So the internal configuration, open means there's no obstacles, barriers, or obstructions inside of a confined space. And obstructed makes it a permit required confined space, and there's something which you would have to maneuver around, such as a baffle or a large mixing blade. Large equipment such as ladders or scaffolding or even lamps brought into a confined space may take it from an unpermitted confined space into a permitted confined space. So you can see in this example how the ladder makes the confined space that much smaller and would make rescue more difficult. And here's an example of an internal configuration for which you can get caught in climbing up and over these baffles, which I've done before in hazardous material cleanup when you've gone inside of a portable storage tank and the baffles keep it from sloshing around, or a blade inside of a large mixing unit. And here's another example of a confined space where the person is wearing a self-contained breathing apparatus. So elevation, it's a permit required confined space if the way that you enter it is more than 4 feet above or 4 feet below grade. And this designates it as a permit required confined space. If it's more than 4 feet above grade, you might have to use ropes and high angle rescue. If it's 4 feet below grade, you probably have to use a tripod to put into place to not only lower equipment, but to perform some kind of rescue procedure or just be ready to perform a rescue. So this slide, although somewhat busy, definitely indicates or displays to you the different types of confined space entry portals, where you could have to be on an elevated surface and then an elevated entryway. And then we have one that's less than 24 inches and one that's greater than 24 inches, both of which would be permit required because rescue could be difficult. Then you can see where you have bottom entry, and so this would be opening greater than 24 inches and an opening less than 24 inches. And then we have the same type of setup but on the ground as opposed to an elevated surface. So this would be greater than 4 feet, all permit required confined space, all permit required confined space, even going down into a sump or a trench. And then you have going more than 4 feet below grade would also be a permit required confined space. And so unrestricted, it's greater than 24 inches and allows free movement into and out of the space. This would not be permit required. Permit required, it's less than 24 inches and or is difficult to come into and out of. So here again is an example of a confined space, and also highlights the importance of proper lockout tagout. So you'd have to lock and tag out all of these areas before you make your entry into the confined space. And you can see the DOT placard on the side of the blasting booth. So just a reminder, and we're going to cover this, we haven't covered it yet in this class, that lockout tagout is also important with confined space, and it's found in the same area. That's that Subpart J, General Environmental Controls. The atmosphere of a confined space, you need to monitor for it. And one way that you can ensure that it isn't oxygen deficient is that you ventilate it before you go into the confined space, and you monitor while you're in there. And so this is just a great picture of confined space entry. You can see these people are wearing climbing helmets, not hard hats. They have fall protection equipment on. It looks like they're in level C. Nope, level D clothing, they're protected without protecting their faces here, so this would be level D clothing. You have backup people as well as a supervisor who's assisting with the job. And so a great example of confined space entry where you're going into a tank of some form. So confined space entry is an action by which a person passes through an opening into a confined space that is permit required, and it doesn't have to be the whole person. It could just be any part of the body breaking that barrier between the outside world and the inside world. And so the confined space standard looks like you're seeing here. It has all these different areas to it. Again, you can see that, or maybe you can't see, but this is a well organized standard. It's newer than some of the other standards. So you have these general requirements again about creating a plan, what a permit required confined space is, as well as what the permit looks like, training, and then duties of the entrant, the person who goes in, the attendant who attends the person, as well as the supervisor and what it's like for a rescue service. And so right in the appendix we have the procedure for atmospheric testing, which we're going to cover here. You have this permit in your handout, what a permit looks like, and then you can see that there's a checklist as well as a special entry form for sewers because of sewer gases. And so you have the entry person, the entry person is authorized to enter and perform the task. You have the attendant who is does not enter the confined space but monitors the confined space and calls for rescue. If you can't self-rescue, you call for rescue. And then the supervisor who signs off and deems that the confined space permit is acceptable. So there's always two people involved in a confined space entry. So the duties of the attendant, that's the guy who is, or the girl who's taking care of the person who's going into the space, knows the hazards that may be faced for the entry person, is aware of what kind of behavioral effects could take place if the person who is entering the confined space starts to feel asphyxiated or dizzy, or starts to get that effect like you feel like you're intoxicated, which can happen when you start to lose oxygen supply to the brain, and that's when that carbon dioxide or carbon monoxide is replacing the hemoglobin on the blood. And you need to remain outside of the permit required confined space until you're relieved by another person. And so when we're looking at knowing and understanding the hazards associated with a confined space, I want to bring you to one very important reference guide that we use in occupational safety and health, and it's called the NIOSH Pocket Guide. And it allows us to look up information on different types of chemicals that we find in the workplace. So although we're covering confined space, we're also going to cover some more specific aspects of occupational safety and health. And so what I listed here was Table 5, and these are the abbreviation codes for hazards, as well as the route of entry and the target organ. And this is within the NIOSH Pocket Guide. So I selected the link and I went to the Centers for Disease Control and Prevention, www.cdc.gov. Then I searched NIOSH Pocket Guide and I came up with the NIOSH Pocket Guide. And we can put a chemical in there. Let's, for example, ammonia. And it'll pull up the NIOSH Pocket Guide of ammonia. This CAS number is a number that's specific to that chemical abstract service number. It tells you what part of the Department of Transportation guidebook to go to when you're transporting it. It gives you the conversion from parts per million to milligrams per cubic meter. This is also our exposure limit, so this is where we look at our toxicology. There's an OSHA permissible exposure limit at 50 parts per million. So this is the time-weighted average, and we're going to learn about this, but I want you to see where to get this information. If you needed to sample for ammonia, you can use any one of these methods here for sampling for ammonia. It gives you the physical description as well as the physical properties. This tells me that ammonia can be explosive between 15 and 28% in air. Relative density is 0.6. That means ammonia will go up and out if it's released into the workplace. It's a strong oxidizer. It gives you the symptoms that you start to feel when you're starting to reach that upper end of that exposure realm. Irritation of the eyes, nose, and throat, difficulty breathing, chest pains. You also can find in the NIOSH Pocket Guide personal protective equipment that you should wear, as well as first aid if you're exposed to it. So that's where we go to find our hazards. We go to the NIOSH Pocket Guide. And here's the NIOSH Pocket Guide for benzene. This is actually the book with the NIOSH Pocket Guide as opposed to the website. What's important to note from the NIOSH Pocket Guide is here. These are our exposure limits, the time-weighted average, how much we can be exposed to at 40 hours a week, 8 hours per day for 40 years. As well as our upper and our lower explosive limit, which allows us to determine when we're in an explosive atmosphere. This also tells you here that benzene is a flammable liquid. So the duties of the attendee is to communicate with the attendant to summon rescue. You should perform not rescue duties, which means you implement your plan, and as long as you don't have to enter the tank, you can aid in, or whatever the confined space is, although I always think of a tank, you can aid in the rescuing of the person who may have had some kind of incident or accident. And you're not allowed to perform any duties that would take you away from attending to the person who has entered the confined space. But one of the requirements of the attendant is to perform periodic air monitoring through the entire column of the confined space for which the person has just entered. And so I'm going to go over some occupational exposure limits and flammability ranges so you can understand what the person would be monitoring for. So we're going to just speak about hazardous atmospheres. And we talk about a hazardous atmosphere under the OSHA requirements. We're only going to deal with OSHA, no other governing body. We have a term called a permissible exposure limit. And a permissible exposure limit is the maximum amount of a contaminant that a worker can be exposed to over a 40-hour work week or an 8-hour day. And so the permissible exposure limit is the regulatory guideline. We evaluate a person's exposure using a time-weighted average. And a time-weighted average is the employee's average airborne exposure in any 8-hour work shift of a 40-hour work week. So the 8-hour time-weighted average permissible exposure limit is a level established that's the highest exposure that a person can be exposed to and not have any adverse health effects. So the permissible exposure limit is the regulatory guidance, and we evaluate the compliance or where the person is in relation to that regulatory guideline by evaluating their time-weighted average. And if a worker works longer than 40 hours per week or 8 hours per day, we have to make an adjustment. But that's well beyond this class, so just think of that permissible exposure limit. Or here in this example, NIOSH also has a recommended exposure limit as the maximum amount that a person can be exposed to over their work day or their work week. So another way to look at this is if the permissible exposure limit is 8 milligrams per cubic meter, that would be this red line right here. The action limit is typically set to half of the permissible exposure limit, although not always, and that would be this line here. And then as we go through time, you're actually seeing this person's exposure is a little bit above the permissible exposure limit. Then it drops down to the permissible exposure limit, goes all the way up to our short-term exposure limit, then drops way down below the action limit, comes up again, hits our STEL, our short-term exposure limit, then levels back out. So as long as our time-weighted average, what we're actually exposed to, is less than the permissible exposure limit, the do not exceed value, then the worker is considered within compliance, or the workplace is considered within compliance. So in the world of hazardous materials, we need to pick some values for which we actually set our meters to. So when you monitor in a confined space, you have to monitor both, or not only both, but at the bottom of a tank, or the bottom of the space, at the middle of the space, and at the top of the space. And continually monitor, because people and equipment going into that space cause a mixing. And so the principles behind this are some gases are heavier than air, like hydrogen sulfide, and that sinks to the bottom. Whereas in benzene is lighter than air and it goes on top. So you can have potentially a toxic atmosphere on top, a clean atmosphere in the middle, and then a toxic atmosphere at the bottom, or something like that. We really don't know what's going to happen inside of a tank. So you repeatedly monitor if you can't continuously monitor, and you make sure you monitor at all the different levels inside of a tank, or all the different places in which a gas would stratify. And here you are looking at a gas meter, and you can see that it's measuring carbon monoxide, it's measuring carbon dioxide, it's measuring hydrogen sulfide, and it's measuring oxygen. Tools of the trade in industrial hygiene. So in our atmospheric conditions, you can have atmospheres which may expose employees to the risk of death, incapacitation, impairment, inability to self-rescue, and acute illness or injury. And so we're going to measure, we could measure more than 3 things, but for this class we're going to measure 3 things inside of our confined space. And one of them is flammability. And we set our alarm, so our lowest measurement, at 10% of the lower flammability limit of some gas that we choose. And it's very important to make that distinction that not all gases will alarm at this setting. It's only the gas that we set our meter to. Then we also monitor for oxygen, and that would be an oxygen deficient atmosphere, which is below 19%, or an oxygen enriched atmosphere, which is greater than 23%. And then we monitor for some type of toxicity. And this is usually monitored at some percent of the occupational exposure limit. Hydrogen sulfide and carbon monoxide and carbon dioxide are really common gases that you monitor when people are in confined space environments. And so under normal atmospheric conditions, the concentration of oxygen in the air is around 20.9%. The National Institute for Occupational Safety and Health defines an oxygen-deficient atmosphere as an atmosphere in which there's less than 19.5% oxygen. Also, when you're at less than or at 16% oxygen, this impairs your judgment. Your respiration rate may go up considerably because you're trying to bring more oxygen into the body. So your brain doesn't shut down, your heart doesn't shut down. And at 14%, you have fatigue. A lot of people, you can see that they become emotionally upset because they become nauseous. Around 10% of 10% oxygen, that's where you can actually become unconscious. So people who climb at higher altitudes, they bring oxygen with them so that they could continue to live in that environment, and you become oxygen impaired over long periods of time. It can lead to death, even a slight decrement in oxygen. And you have to think, if there's not that much oxygen, what's the other gas that's out there that may be in excess, right? And so here we have a worker who is wearing a monitor, and they could take it with them into the confined space so that the attendee doesn't have to monitor. And here you can see oxygen, hydrogen sulfide, carbon monoxide, and the lower explosive limit. So in monitoring the atmosphere in a confined space, the standard states that we set our meter to 10% of the lower explosive limit. And nobody should ever enter a confined space that's greater than 10% of the lower explosive limit. So what's the lower explosive limit, or the lower flammability limit? So the lower flammability limit, the lower explosive limit, is the minimum concentration of vapor in air that will allow it to flash and catch on fire. And then you have this flammability range, which means that there's enough vapor for the vapor to burn. And then you have the upper explosive limit, and at the upper explosive limit, it's too rich. It's like you flooded your car. There's too much material, too much vapor, and it will not burn. So we set our meter to 10% of the lower flammability limit of some flammable gas, and we have to choose whatever that flammable gas is. So here we can see a container of gasoline, and when we try to put a spark really close to the surface of the gasoline, there's too much vapors. It's too rich to burn. And then we take our spark and we move it far away from the gasoline. There's too few vapors. It's too lean to burn. And then we put our spark right in that sweet spot where there's enough vapors, and this is the flammability range. So that lower end of the vapors, how much vapor is in the gasoline, would be the lower explosive limit. And we set our meter, when we're monitoring for confined space, at 10% of that value. So our testing protocol: before an employee, an entrant, enters the space, we monitor that space with a calibrated direct reading instrument, and we monitor for oxygen, the flammability, as well as any potential air contaminants. So we set our meter to a specific gas. For example, the flammable range of methane is between 5 and 15%, and so the lower limit is 5% by volume in air is enough that you can create that flash like we saw with the gasoline, and 10% of 5 is 0.5. So that's what we need to calibrate our meter to, would be 5%. Methane in air would be 10% of the lower explosive limit. And if we look at our conversion factor here, we can see that each percent equals 10,000 parts per million. The lower explosive limit of methane is 5% in air times 0.1 gives us 0.5%. That's 10%, which is 10% of the lower explosive limit. And then we multiply this by 10,000, and it means that at 5,000 parts per million, we're at 10% of the lower explosive limit of methane. In atmospheres that are oxygen deficient, an air supplying respirator must be used. This type of respirator is a full-face respirator that supplies air from a cylinder that the worker wears on their back, or a line that runs to the respirator from a fresh air source. In atmospheres that have enough oxygen but contain contaminants, an air purifying respirator could be worn, or a cartridge respirator could be worn. So if there's not enough oxygen, you have to wear an SCBA, which is very much like what a scuba diver wears, but we take out the U for underwater, and we don't wear it underwater, and it supplies us with fresh air. This is if the work area is not characterized very well, or if it's an oxygen deficient atmosphere. If it's a toxic atmosphere but there's enough oxygen, we can wear an air purifying respirator, which does not supply fresh air but purifies the air through a pump with a filter, or we can wear a cartridge respirator, as you see here. You also have to provide adequate illumination inside of a confined space and ensure that that illumination is intrinsically safe, so that just in case there is a flammable atmosphere, your lights don't cause you to have some kind of spark, and that's when you can actually have the vapors ignite, which is much easier than you would think. Enough static electricity can be generated just through the transferring of a flammable liquid to cause a spark that can cause the vapors to ignite. So we talked about the attendee. Now we need to talk about the entrant. The entrant is the person who enters the confined space, and they're faced with the most danger. Again, as part of hazardous communications, they need to know the signs and symptoms of what it feels like, or what it may feel like if they're starting to get negative effects from the atmosphere that they're in. They need to be properly trained on their equipment and have methods to communicate with the person who is attending. And so knowing the hazards is part of the hazardous communication standard. The supervisor verifies that the rescue plan is in place and that there's an available means to summon somebody, whether that happens to be calling 911 or you have staff on site that can rescue, and that can be used in the location that you're in. Sometimes you're in remote locations. Your cell phone may not actually work. They can also remove unauthorized people from the work area and transfer the confined space permit from person to person if that needs to happen, and the supervisor is the only person who can close out a confined space permit, which is very much the same as lockout tagout.
Two night shift employees were moving lighting and spray painting equipment inside a barge to continue a painting operation. Employees on the previous shift had been painting in the confined space continually for 10 hours. The paint mixture being used was flammable. The lighting equipment was not explosion-proof. There was no ventilation and only one open access hole. Painters and laborers constantly entered the confined space without any air monitoring. As the two night shift employees set up the equipment, a spark ignited the flammable paint vapors and caused a flash fire. Both employees were killed. Sufficient ventilation would have kept the concentration of flammable vapors below 10% of the lower explosive limit. A shipyard competent person should have visually inspected and tested the confined space for oxygen content and lower explosive limits prior to entry by employees and found the flammable atmosphere. There should be no plugs or electrical connections within 50 feet of hazardous atmospheres and painting operations. Explosion-proof lighting and equipment must be used when spraying flammable liquids. The employer did not make sure that employees entering confined spaces were properly trained to recognize hazards. Although not contributing to the fatality, electrical cords and open access holes presented 2 additional safety hazards. Electrical cords and painting hoses should not be in the way of workers using the ladder. Clear interference with ladder access as much as possible. Open access holes and decks should be adequately guarded to prevent employees from accidentally falling down them.
So in addition to the attendant, so the entrant is the person who goes in the space, the attendant is attending the entrant. You can have a designated rescue person, and so that's a third person. And then that third person would be able to go into the confined space if there was an incident, still leaving one person on the outside of the confined space. So this person can also be the dual role of the supervisor. A lot of times the supervisor will just check you out and leave the space. Other times the supervisor checks you out and then can be the designated rescuer. When I worked in hazardous materials, we always had 3 people on site. One in the space, one that was attending the space, and one who was the designated rescuer. And retrieval systems when you're going underground are really important, and you can see the harness, the D-ring, and the retrieval system, which is the tripod. And we're going to cover this at the end of the semester in Walking and Working Surfaces. We'll also cover the requirements for fall protection. So some other hazards, you have falling objects, insects, biological hazards. I've been down in sewer holes before. Some pretty nasty stuff grows down there. And a confined space sign, keep out unless authorized, and so you should always have signage in place. So your written plan, as it's outlined, there is a section in the instruction itself which helps you with the plan, where you have to identify the confined spaces within your organization previously, and then you have notification and warning, which is this sign, and hazard identification. This is all done pre-event. I've seen confined spaces where the confined space permit was, with all the hazards listed on it, was like a laminated piece of paper in which you can write with a grease pencil on and then erased, so that it was always like attached right to the confined space. This is something that sometimes interns do. They help to update the confined space entry forms. So then when you enter, you have equipment for, or previously, but for entry, you'd have equipment for exiting and entering, and your permits, as well as your authorized personnel. You outline who your supervisors are, what your rescue procedures are, and what closeout looks like. And you have a copy of one of these. It's a confined space permit. You could see where you would be testing oxygen, carbon monoxide, and hydrogen sulfide. It gives you the acceptable conditions for these, which is far below the permissible limit. It's some percentage that's low enough that the alarm goes off. So we don't want to be working at the permissible exposure limit unless we're suited up appropriately. And you can see the training that's in place, or not the training that's in place, the monitoring that would occur, who the emergency personnel are. reasons for terminating the permit, and that all the hazards have been previously checked to conclude oxygen deficient, flammability, permissible exposure limit, whether the material is harmful to the skin or not, whether it's a dermal exposure, noise, slipping and tripping hazards, whether there was asbestos in the area, hot or cold stress, engulfment, something that can fall in where electrical hazards blanked off. And then did you have cold running water or warm running water? And were there any snakes, rodents, or spiders in our confined space? All sorts of good confined space stuff for you. So here's a summary of what is required for entry into a confined space. Really understanding all the parts of this form are important, and it helps to summarize confined spaces and as well as understand the requirements within the standard. Again, it's 29 CFR 1910 under Subpart J, General Environmental Controls, and this one is Permit Required Confined Spaces. I thank you and hope you have a great day.